Greetings everyone, Dr. Doherty from Abilene Christian University. Here's a quick video about how to add vectors using pictures instead of math. So for this problem we're going to add three vectors. So I've got a x and y coordinate system, and remember, positive x points to the right, positive y points up. So my red vector has got an x of positive 2.5 and a y of 3, so that puts it up and to the right. The blue vector is negative 2.5, positive 3, so up and to the left. And my green vector is 1, 2, 3, 4, 5 in x and 0 in y. Now if we're going to add these, you might be tempted to break out SOHCAHTOA and trig and our good friend Pythagoras, but you know what? We can actually get the right answer just trying to use pictures instead of equations. So let's do that. It's going to help us out a lot as we tackle vector problems in the future. Okay, so the way that this game works, you pick any vector that you want and you add the other vectors to it by moving them around until they're all lined up head to tail. So for example, I can pick my red vector here and just click and drag it so that it's sitting head to tail with the blue one. Alright, so my red vector is sitting right here. Now I take my green vector and I put it head to tail with the red one, and we're done. So the sum of this, let me grab a new line here, the sum of these three vectors points from the beginning of the first one to the end of the last one. Let's take this line maybe and I'll make it purple and a little bit heavier. Let's make it an arrow, and I'll throw in some dashes because it's a special dotted line. Alright. So the sum of blue plus red plus green is now this purple arrow. That's it. Now adding vectors graphically is really important for doing reality checks. This is the important last step of any problem to make sure that we got the right answer. It can be really easy to forget a negative sign in a component, accidentally do a sine instead of a cosine, and checking the components with what our answer is compared to the graphical picture lets us know if we got something right. But let's double check this. Let's say that suppose instead of starting with blue, I started with a different vector. Maybe I went with red first, and then I added green to red, and then I put blue on the end of green. We get the same answer. Maybe instead of starting with red, we did the green first, and I put the red on that one, and then I put the blue on that one. It's the same. Or I did green, then I did blue, then I did red. You see, it doesn't matter what order you put the vectors in head to tail. You have to get the same answer every time because math doesn't care what order we add things in. So for any vector problem, I can draw a careful picture to scale, I can stack up the vectors head to tail, and I can see what the answer is. This picture shows four possible ways that we could have added red, green, and blue head to tail and still gotten the exact same answer anytime. So do them in whatever order you like. It always works out. Okay, let's check this now with the actual answer. So if I were to do this with math instead of with pictures, what would we get? So the way that you add any vector is to make a table of the x and y components. I made another video about this if you want to check on that. So this is a pretty easy problem since we've already been given the x and y components of everything, so we can fill these in. So my red vector has an x of 2.5 and a y of 3, so on and so forth. So now when I have my x and y components written down, I'm basically done. The x component of the sum vector is just this plus this plus this. 2.5 minus 2.5 plus 5. The sum of the y's is the sum of the y's. So when I type those numbers in, I'm going to have a 5, 6. And sure enough, that's the purple vector we've been looking at all along. Its x is 1, 2, 3, 4, 5. Its y is 1, 2, 3, 4, 5, 6. So whenever you get a vector problem, before you even write down a single equation, you should draw a careful picture, move the vectors up head to tail, and that gives you a great estimate of the solution That tells you which way the right answer points, about how long the right answer is, and it's a really, really great way to check the answer that you've got from math. That's it. Thanks for watching.